In the last video, we talked about extending a function that's defined on the interval from 0 to t to a function that's defined from negative t to t. And we saw that we can make it periodic with period t, but we can also make it an even function with period 2t and an odd function with period 2t. And when we extend the function, those extensions will have Fourier series. And we're going to look at those Fourier series of the odd and even extensions. So suppose that we have a function f, which is piecewise continuous, on the interval from 0 to t, and we let f sub e for even, be the even 2t periodic extension of f, and we let f sub o be the odd 2t periodic extension of f. So for example, suppose that your function f looks like this from 0 to t. Looks like part of a parabola. Well, in that case, you are going to have an odd extension and an even extension. Let's look at f sub even. So f sub even, okay, we're going to make it go from negative t to 0, and we're just going to reflect it across the y-axis. And when we do that, you're going to get this. And then you would, well, to make it, notice that it would be continuous if we defined it at 0. So let's just define it at 0 to make it continuous. Okay, so now you have this piece from negative t to t. It's even from negative t to t. And now we just extend it so that has period 2t. So we just shift it to the right and left forever. So it's going to go from t to 3t, because t plus 2t is 3t. And then it's going to go to 5t. Oh, these are not very evenly spaced. And then it's going to go to 7t, etc. And then it's going to go to the left forever. So negative 3t, negative 5t. Okay. And so we just extend it, so it's going to look like this. And it's just going to keep going on forever. And we can even define it at these points to make it continuous. Okay, that's what f sub e looks like, the even extension. Okay, what about the odd extension? So we are back to where we were before. 0 to t, you have this piece of a parabola. And to make it odd, so from negative t to 0, we rotate it by 180 degrees. That's going to make it look like this. So now this is going to be an odd function from negative t to t. Now that we have that, we just extend it so that has period 2t. So it's going to look like this. Oh, no, not like that. Like this. Okay, So these are the values at t, 3t, 5t, 7t, and then at 4t, it's here, and 6t, it's here, and 2t, it's here. Okay, and then it just goes on forever. Like this. Okay. So that is the odd periodic extension f sub o. So these are periodic functions. They're piecewise continuous, so they're going to have Fourier series. So the Fourier series, let's look at what the Fourier series of the first one is. The Fourier series of f sub even, f sub e, well, by definition, that's... So notice that since this is even, we will not have sine terms, right? We're only going to have cosine terms. So it's going to be a sub 0 over 2 plus the sum from n equals 1 to infinity of a sub n times cosine of n pi x over t, where a sub n is the integral, it's 1 over t times the integral from negative t to t of f, well, you're looking at the Fourier series of f sub e, so it's f sub e of x times cosine of n pi x over t dx. However, since f sub e is even, okay, we know this is going to be 2 times the integral, okay, from 0 to t. So you're going to get 2 over t times the integral from 0 to t of f sub e of x times cosine of n pi x over t dx. So that's because f sub e is even. So now you're doing this integral from 0 to t. However, okay, from 0 to t, f sub e is the same as f, right? So this is going to be 2 over t times the integral from 0 to t of f of x cosine n pi x over t dx. So that's a sub n, where n is 0, 1, 2, etc. So this Fourier series, the Fourier series of f of e, okay, which is defined to be this, where a sub n is equal to this Fourier series is called the Fourier cosine series of your function f. Fourier cosine series of f. Similarly, we have a Fourier sine series. Now, it's called the Fourier cosine series, obviously, because only cosine terms show up. So similarly, if you look at f sub odd, okay, so that's the second one, that will also have a Fourier series. And that's the sum from n equals 1 to infinity of b sub n times sine n pi x over t, where the b sub n is 2 over t times the integral from 0 to t of f of x sine n pi x over t dx. This is for n equals 1, 2, 3, and so on. And then this series is called the Fourier sine series of f. Okay, this series, where this is your b sub n. So that's the Fourier cosine series and the Fourier sine series. It's the Fourier series of the even and odd 2t periodic extensions of your function. And in the next video, we're going to look at an example of calculating the Fourier cosine or sine series.